Section 4.3, we want to introduce the tree diagram for a couple have 3 children. The formula that we use often is this: probability of at least one is probability of one minus probability of none. And then the second one is conditional probability. So when you have probability of BA/A, it means event A happened first, and then event B. So event B is depend on event A. First, I want you to see a tree diagram for a couple who want to have 3 children. So in this case, when the first baby is born, what's the probability of having a boy? 0.5 or 50%. Having girl is 50%. And if the first baby is boy, what about the second one? It could be boy or girl, or the third one could be boy and girl, and vice versa here. If the first one is girl, the second one would be boy or girl, and so on. Now, then you go through the trees, through the branch of this tree. What's the probability of all 3 of them are boys? 0.5 times 0.5 times 0.5. So in that case would be 1/8, and so on. So what's the probability of all of them are girls is 1/8. So based on this, you are able to answer any questions like, what is the probability of having 2 boys? You look to see all these 8 possibilities. Which one has 2 boys? It's this one has exactly 2 boys. Another one. So 3 out of 8 are exactly 2 boys. Or what's the probability of at least 1 boy? At least 1 boy is 1 minus probability of no boys. No boys means all the girls. So see, all of them have boys except this one. So it's 1 minus that. This is another example that it shows you this probability of the tree work for basically a lot of practical problems. Like here, a patient is allergic to penicillin is 0.2. What if the person is not allergic? So it's 0.8, and so on. Now, again, on the first part, you want to apply this formula. Event A happened first, and then event B. That's why we select that one, because here is the word given. Given is this slash here. Given, subject is telling the truth. Subject is telling the truth is event A. So that happened first, and then before the given, which is B. So this slash means where the given is. So event A happened first, and then B. B is polygraph indicate that subject is lying. That's why the second one is correct. Now, find the probability that when a couple have 3 children, at least one of them is a girl. Probability of at least one is 1 minus probability of none of them are girls, or all boys are the same. So we discussed that here, that probability of all boys is 1/8. So it would be 1 minus 1/8, or 7/8. As some boys and girls are equally likely, probability of a couple having a baby boy when their 6 children is born. It doesn't matter whether you have 6 or 7, 8. The probability is always boy or girl. So it's always 50% chance. This has nothing to do with the trees. That's kind of trick questions. So a couple having a boy, their 6 children, has nothing to do with what they had before. Now, in this one, probability of baby girl is 0.4688. Assume the next 7 randomly selected bird is in the country. What's the probability? At least one. Probability of at least one. Probability of at least one boy is 1 minus probability of all girls. Probability of all girls is 0.468 to power of 7. Now, the last one. Subject for the next presidential election poll are contacted the telephone number in which the last 4 digits are randomly selected with replacement. Find the probability for such a phone number. The last 4 digits include the 0. So, last 4 digits of Social Security. It could be any of these 10 numbers. So there are 10 digits here. What is the probability of at least 1 0 is 1 minus probability of no 0. So when you look at the last 4 digits, if there is a 0 in it, it's 1 out of 10. One of these numbers is 0, 1 out of 10. What's the probability of no 0? 9 out of 10. So the formula is 1 minus probability of no 0, which is 9 over 10 times 4, because they are talking about 4 digits, and that's what they give you this number. So these are all based on that tree diagram I showed you. Now, these problems are all based on the formula. So when you have a table here, find the probability of randomly select student who spent the money given that a student was given for. Given, after the given, this event happened first. For a student was given 4 quarters. A student given 4 quarters, how many are they? 45. And then how many of them is spent? Purchase or spent? 30. So 30 out of 45. Or the second one, find the probability of selecting a student who kept the money given. Again, this after the given. A student was given 4 quarters. A student's given 4 quarters, there were 45 of them. Out of this 45, kept the money was 15. 15 out of 30. Here, find the probability of selecting a student who spent the money given. A student given $1 bill. How many students were given $1 bill? 40. Out of this 40, how many is spent? Purchase or spent? 13. The second one, $1 bill, again 40. How many kept the money? The kept the money is 27. Same thing here. Find the probability of selecting a student who spent the money given that student was given 4 quarters. Student was given 4 quarters, again, is 49. And out of this 49, spend the money, out of this 49, spend the money is 33. Probability of selecting a student who spent the money given a student was given $1 bill. How many students are given $1 bill? The total is 41. And out of this 41, how many spend the money? Out of this 41, 15 are spending the money. Now we go to the second one. Again, on this one, assume one individual from the group randomly selected. Find the probability of someone who tested negative given that he or she has the disease. So this event happened first. How many have the disease? Yes, 145. So out of this 45, how many are negative? 20 out of 145. Again, this one, the probability. Find the probability of selecting subject with a negative test result given that subject has disease. Subject has disease happen first. There are 3, yes. Individual had a disease, yes, 359. And out of this 359, how many are the negative one? 18 out of 349. And the rest are all multiple choice that I put the keys here for those questions.